So without further ado, let me introduce today's speaker. We're really happy to have Dr. Lesley Mayne here with us. She is an assistant professor in the Communication Sciences and Disorders program. She has 20 years of clinical experience working in schools and private clinics, and 7 years of university teaching experience. She is the author of Let's Talk Social Skills and co-author with Dr. Sharon Rogers of the book Augmentative and Assistive Communication with Children, or AAC. Her current research interests include a pedagogy and AAC that includes autism spectrum disorders and attention. Thank you.
Okay, thank you very much. Well, thank you for having me at this forum. It's exciting to present to peers. So thank you for having me. So today we have a brief amount of time to go ahead and talk about what we know about the neurobiological basis of autism, and on top of that, what can we do? What are we looking at that can support some clinical decision making regarding attention? Because it's frequently a topic that everyone deals with clinically, but everyone's really not sure what to do. Why is this occurring? So just a little bit about myself. I joined here a year and a half ago, so I'm new from Southern California. Just absolutely love it here. I don't have time to go in on everything, but thrilled to be here. So thank you to Dr. Sather, who was a key instrumental professor in bringing me here. All right, so for today, we're going to take a look at what we know about analyzing attention. Hopefully, you'll be able to list some of those characteristics that contribute to attention, and then talk about a framework that's analyzing communication behaviors of a child with ASD. So we're going to have two parts to this. One, just getting a feel for what autism is, just to get oriented. If you're feeling really strong, I can go over this part faster. So let me know if I go too fast. And then the second part is to take a look at those factors neurobiologically and implications for what we're seeing. Okay, so autism, always unique, totally intelligent, sometimes mysterious. Okay, so the DSM-5, the Diagnostic Statistical Manual 5, 2013 edition, had updated its definition of autism. And so we're looking at persistent communication and social interaction deficits. So this isn't something that happens on occasion. It's not something where maybe you get nervous and don't interact well in major group situations. This is a persistent, across circumstance behavior, along with the persistent presence of restricted, repetitive patterns of behavior or interests or activities. So that's the general definition. So my question to you is, do you recall seeing attention as a clinical marker in the range of deficits for a child with autism? Was it there? No, it wasn't. Yet in the background, if you're working with a child with autism, it's screaming at you. And over I am asked, what do we do about attention? So we look a little bit further into some of the characteristics, and we can see some additional circumstances. Maybe as a child develops, you might see some of those masked behaviors. You might see degrees of intellectual development or intellectual impairment. Maybe you won't. Same thing with language. Language may be fully developed. And when we talk about structural language, they're talking about morphology, syntax, so the actually putting together of language rather than the pragmatic issues that we traditionally see with autism. So there could be the actual formulation of language components. All right, there could be genetic, there could be other medical, neurodevelopmental, could be related to age, meaning starts to develop typically and then has a form of regression, and then severity. So what's going on? What do we see? Clinically, when we're observing a child, we could see any one of these areas. Usually there's a complete circle, you can see it there. I added these two extra circles at the bottom. I think if I go away from me, am I allowed to walk over here? Okay. Some children with autism may present with seizures, and usually there's a genetic component there that helps identify that. And then genes, just is, yes, while we don't observe genes, you can observe seizures. So we take a look and say, hey, we might see any number of these issues present. Okay, so what I'm going to have you do is watch a video just to practice with your observational skills. So we're going to watch Thaden and get a feel for what you think is going on with his attention. While you're doing that, I'm going to give you a couple ideas. Just take a look here. We've got those areas of concern. And I want you to observe those areas as well as identify strengths for this child. So again, when you're thinking about what are you observing, social interaction, verbal communication, nonverbal, behavior, sensory, motor, adaptive skills, self-regulation. So these are areas that we take a look at. If you're new to this, that's fine. Just watch. What do you see going on with autism? But what do you see, again, as a strength?
You gonna come down the slide? Hi, can you sit? Jaden, sit. Hi. Hi. Be careful. I think that we're gonna have to fix the playscape now. That's a little dangerous for you. Can you go down the slide? Go down the slide. Ready, set, go. No. Thaden, can you say hi? Ready, set, go! Yay! Good job! Wow. Mommy's gonna have to help you. Want help? Say mama. Steven, you want help? Me? Steven, look. Say mama. Help? Me? Good job, buddy. I'll help you.
All right. So you had a chance to take a look at that. Let me show you some of the characteristics that I saw. Do you guys want to comment on anything that you saw that was indicative of attention, things you were, or strengths that you saw? If not, you can go off of my... Imitation, okay. So we got some verbal imitation going on. And very quick too, right? It wasn't the same intonation as the mom, so maybe we're thinking with that production, it's very apraxic. Got it out, but it's very quick, jagged, without the prosody intonation that we might expect. Okay, so when I'm looking, oh, you're not looking at it. I think I need to slide it over. Okay, there we go. So when we're looking at some of his strengths, and of course I get the benefit of knowing this video and having been having done this a long time. I don't know what that is. We'll just put you over there. We have strengths. He had eye contact on his timing. He had this engaging and inviting smile. He had this expressive verbal imitation. Thank you. One spontaneous use of sign, evidence of maybe a deeper vocabulary base than what we might perceive. Interest in the outdoors. He likes movement. Interest in manipulatives. Okay, so we've got a number of strengths, which is great. We also have a lot of observations we can take a look at. So he's looking off into the trees. No evidence of attending to the parent for social greetings. Some staring, a little bit of vocalizing, but it wasn't purposeful. Sensory seeking with the grass. Was he attending to the touch and that sensation when he went down? Again, that very apraxic-like production. That spontaneous use of all done, so he's definitely learned that. That's effective for him, so that's good. But these are just general observations that I'm sort of seeing that I want to know more about. Get back to my... Okay. Let me see if this works. Okay, it works for you. I think I lost my... There we go. Great. All right, so let's go back. So now, if you could characterize his attention, you've got probably an idea, but are you confident that you can really classify what he's done? And so that's what I really want to investigate and what I'm spending time in my research doing. So now we're going to take a look at those neurobiological markers, some of those factors, and then talk about a tool that I'm working on putting a research study together with. So when I was asked about this, I was giving a presentation. They said, hey, we want you to talk about language development and AAC, that's the augmentative and assistive communication. And I said, okay, was there anything that your viewers are consistently asking about? And they said, yeah, we don't understand attention. And it's not really being talked about, and we don't know why attention is such an issue. So I said, sure, I can answer that question. That headed me down a path I had no idea I was going to be exploring. And it took me really straight to the neurobiological basis of autism and what we know to date. So I will give you the short story of what that is. So taking a look at the genes, taking a look at the environmental aspect of that phenotype. So you've got the genes, and then the environment, which neurobiologists consider within. So once the environment within the body, essentially, and then the epigenetics. So what's the expression of that gene? What is it looking like with neurite growth? What's it looking like at the synaptic level? And then the cytoarchitecture of cell development itself. So don't worry if none of that made too much sense. If it did, great. When you're taking a look at the brain, these are the areas that are being implicated or being studied presently. So this will not be a neurology test, but it is a general idea that we're taking a look at what's going on in the motor. We're taking a look at higher level thinking. We're looking at this information processing area. We're taking a look how visual information, including some further, this actually goes all the way across. This is my very bad drawing of the brain. And then the cerebellar vermis. So what's going on with all those areas, from the repetitive movements, higher level thinking, language, movement, yeah. So lots of things going on there. So we've got this static view, and that's helpful to identify markers, but this is really what's going on in the brain, is this massive information highway. And understanding what's happening in the brain, where do we have these breakdowns, and they've have brain images similar to this of people with autism, and they'll see a diffusion of these neuronal networks. Okay, so someone that's, say you're trying to go to your friend's house and you've been driven there a bunch of times, okay, but now you're driving yourself. Okay, so that person that was driving had that full complete network, knew exactly what they're doing, where they were going. So you are driving your first time, and maybe this has happened to you, maybe it hasn't, but you're driving, you're doing fine, you're heading down the freeway, and then you get off the road. It's like, yeah, I recognize that off ramp, and then you head down to the main sort of road, doing fine, but as soon as you head into the side streets, it's like, oh no, I don't remember where I'm at or what I'm doing. And that is similar to what's going on. We have this in some kids with, or adults, this diffusion of these neuronal networks. So the information highway is not as complete as potentially it should be. So what do we know? We know that it's complicated. We know that no genes are directly causative. However, abnormalities have been found in every chromosome. Okay? We, in certain studies, have abnormal brain growth in the embryonic stage, so there's too much by 67%. And in a few percentages, I think there's a 20% higher incidence of children with autism who have this perception of having an enlarged cranium. And when this first came out, I was in practice and I went back to school that day and I looked at all my kids' heads. I'm like, this doesn't work. It didn't fit my case. It's like, okay, so we know this is with some kids, but it's not with all. So it really didn't help me very much, but it was still interesting to know about. So we've got this abnormal brain growth. We've got the neurons and the morphological development. So how these cells are layering together puts together, maybe if you think about it like reading, it's words are put together in a certain order that help you understand. When those are mixed around, when the cells are not landing and layering the way they should, you have this different expression. And then also implicated is the synaptic plasticity. So as information, even if the information is coded correctly, the DNA, and it's headed down the path, if there is in the excitatory inhibitory phase across the synapses not strong enough or too strong, it heads off and takes that information into an area where it shouldn't be. Okay, so they're looking at 1,000 ASD causative risk genes out of 20,000 in the human body, which is also being debated actually, because they used to think there was 100,000. Then they took it down to 25,000, depending on who you read. And they're still debating. Some say no, it's closer to 50,000. So we're still figuring out what a gene is while we're trying to figure out and understand the complexities of the brain. Okay, other issues, copy number variation, which happens whenever we have a child who's conceived. We've got copy number variation and there's changes, but is that potentially contributing to autism? Okay, so while no one gene confers this pathogenesis, we know that there is, and it depends on the study, that's why you have this about going on, somewhere 15 to 20, 8 to 20, some say a little bit more, some say a little bit less. The Simons Foundation Autism Research Initiative is taking a look at genes, and you can see, at least right now, what's being studied. High incidence Swiss syndrome, particularly Fragile X. So they have 25 genes that they feel are highly confident to be associated with autism, and then you can see as it moves on down, and there's a number that have not yet been measured. They're also seeing associated disorders. So just because they're taking a look at these genes, it's not autism specific, but related to potentially attention deficit, hyperactive, ID, epilepsy, obsessive compulsive disorder. So many different syndromes and diseases and issues being addressed. So I had to figure out what I was going to do with all this information. How do I capture what I see going on in this research that was pretty heady to capture? So these were the general areas that emerged from the literature. So the idea of copy number variation, changes in the genes as copies of humans are made. That copy makes sense though. There's a reason humans give birth to then look like other humans and not pencils, right? So there's a genetic, not that pencils have genes, but you know what I mean. So rearrangement and position effect. So were the gene segments, we tend to think about this more with chromosomes, but it's the same with genes. Have they been rearranged and now that's causing issues? Is there been a mutation of the gene? Chromosomes, was there deletion or duplication? Was the chromosome section inverted or is it in the wrong location? Synapses, is it the development or the start of those genes or the synapses? Is it the function of the synapse itself is not working, or is it that excitatory inhibitory motion or phase, that neuroplasticity or synaptic plasticity that is implicating what's going on? Is it the neurons? Is it the development of the neuron, the growth of the neuron, or the migration, which is what I talked about before? You're getting lost in what you're trying to accomplish because you don't have the neuronal strength in the area to communicate, to have higher level thinking, to drive that ability to stop a stemming behavior or repetitive behavior. Is it cellular activity? So is there something going on within the cells? And they're looking at mitochondria. Okay, they're looking at calcium. Cell-to-cell adhesion. Are we looking, and that's again where we get into that idea of, are the cells working and staying together the way they should, layering the way they should? Or is it back to translation, gene expression? And then that takes you right back to genes again. So this is sort of the areas of research that are being studied. Now, we talked about environment within the cells or within the body, but these are areas that are also being studied that are external, truly external environment. Because these are studied doesn't mean they are being, or that they're implicated. It's just these are the areas of study, and you've probably more closely associate the idea of environment with these particular factors. All right, so that was in a nutshell, and now I have a few minutes to tell you what I'm working on. So this is just the start of the profile, and since I worked in clinic for so long, I didn't want to just study this and present the information and be done with it. I wanted practitioners to have something they could actually use. And by the time I was done or feeling like I had a good review of what was going on neurobiologically, I created this tool. So we see these behaviors presenting or as attention is impacting these areas. So we have the somatosensory. Well, you can take a look at them all. I'll see how far I can get in showing you some of these ideas. So as I present and move forward, I'm going to present this information in a way from the person with autism. So you might say, hey, why aren't you paying attention? Why is this person not paying attention? Okay, well, that person could possibly say, well, I'm processing somatosensory input. I'm just trying to work. Maybe we talked about the synaptic plasticity. Its influence, that long-term potentiation is really just that crossing. Is it too much or too little? So what is going on there from a somatosensory perspective? I'm trying to manage my body and get it through space. I need to move that mouse. I'm presently facing this direction and I can kind of reach it, but I've got to tell my body to do this, and it's not moving. And this happens with our kids. So something that I want to know, what's going on then? Beyond just physical movement, what does this mean for my person? If they're seated, if they're walking, their balance, their gait, is that an issue where they need to focus on that? And they would love to answer your question and say hi to their friend or look at that bird in the sky, but they're focused on their somatosensory system of just trying to manage light and sound, tactile, maybe the information they're getting from the ground, whether it's they're on rocks or snow. I can add that to my repertoire. Wherever they're at, okay, thinking about that gait. Visual processing, why aren't you paying attention? Well, my brain's classifying you by your features, not your facial expression, nor the implication of your expression. So they're discovering that people who are neurotypical use the inferior, yeah, I have that, yes. So kids with autism, people with autism use that inferior temporal gyrus to process information. And what they should be, if I go, well, I don't want to go all the way back, but the area of the brain that would typically be used to process facial features, and I know you because I see your face, is being processed in an area in that inferior temporal gyrus that is meant to identify colors. It's meant to identify basic things like anything. I pick up a, that's a chair, that's a table, but I don't personify that. So I'm trying to use this inferior part of the brain to classify who you are. It's just overtaxing this system. It's asking too much. So from a practice perspective, what does this mean? Do I, when I'm working with someone, am I seeing them overly attend? Are they under attending? What's their spacing? What they're doing with their vision? Are they using their peripheral vision? I had one boy who read text using his peripheral vision perfectly. In fact, we didn't think he was reading. We didn't think he was paying attention. Then we would ask him questions. He could answer every question. We're like, holy cow. Or he might have just been photographic. He looked at it, saw it, and he could answer questions. It's just like, okay. And so then we start making these kids work harder to prove it to us. Prove to us that you know this. So the expectation that we put on kids is just a lot. Okay? Why aren't you paying attention? Well, I hear the click of the toy car as I pull it back, and you heard the school bell ring, or maybe the fire alarm. That didn't process at all. So are they listening? Are they processing? What are they filtering in and out? And this whole idea of sustaining, shifting, directing attention is a big issue, and they have highlighted that role within the basal ganglia and processing, considering it that bouncer of the brain. I really like that idea. It gives a nice visual of that information, what's being allowed to stay in, what's not, including motor. It's not just cognitive information. All right, so proximal distal. What does that mean? Do I have somebody who's under-responsive, less responsive, overly responsive? I want to know that information. If they're close, same thing. Are they under, over? What does that look like? Now, does every person with autism have all of these? No, they don't. But these are things that I want to ask and find out. All right, auditory processing. Why aren't you paying attention? Well, I need time to process what you are asking me to see, to hear, to touch, smell, or taste. Now, this is where I couldn't flesh it out because auditory processing starts to capture, unless you're visually impaired, what you're seeing, what you're feeling in relation to what you're asking them to accomplish. So it's hard to just isolate unless, again, you're taking some of these factors out. But recognizing what's happening. So I asked you to look outside the window at something cool, and you start cycling through every memory of a sound, trying to locate what it is you're trying to say, to look out that window, and you look up at the back of the seat, and there's that book I was looking for. Oh, wait, I'm supposed to be looking out the window. You head to the window. There's a streak on that glass. Oh, wait, I'm supposed to be looking at whatever it is I was supposed to look at outside, and that was long gone. Okay, so this whole expectation of processing is implicated. So what does this look like then? What's the number of seconds or minutes between statements or directions that it takes for somebody to respond? Okay, when would we need a break? What strategies do we really need to support communication partners so that they know maybe what the triggers are? What are those observations? So I had a little boy who got triggered by cows. Keep in mind, this is California in the city, and there were no cows anywhere. But if a cow came on the screen, polite, 3-year-old in his little cubby, so imagine those little preschool videos, and he gets up, he takes his little cubby chair, he pushes it, kind of like, I'll be back, heads over to free time, and completely pragmatically appropriate, but had this over response to cows, and it was hilarious. Kind of like, oh, excuse me, I'm double booked. I'll see you, see you tomorrow. Oh, it's hilarious. Okay, tactile. Why aren't you paying attention? Well, like you, my visual cortex, auditory cortex, and hippocampus are ignited. So I'm thinking, I'm hearing, I'm recalling, I'm learning, but my neurotransmitters are firing differently. So I have issues trying to maintain my attention, shifting my attention, having selective attention on what you want me to focus on. Okay, so some recommendations are to work on gross motor, work on fine motor to help kids be more successful. So I had another kid, and he's crying and crying and crying. It's in the preschool classroom again, and they come to me, what, do something, he's just crying and we can't get him to stop. Okay, and they were trying to work on this matching task. I said, okay, let's take these markers, or the puzzle pieces or whatever it was, to work on language, put them on a different table and just get him physically moving. And that physical movement allowed him to orient. Now he cried actually for a little bit while he started to regulate and complete the task. and then he regulated. So can we do something to change the tactile experience to help him get regulated? And it worked. I try to include movement whenever possible with my kids, especially if they're in a place where they're stuck. All right, so I want to know, what are they overly attending to tactily, under attending, and potentially any triggers from a touch perspective? So some kids, well, think about the little boy you saw, Thaden. He went on the ground, he's touching. And what was he doing? I don't know what he was doing. Was he deciding whether this was a problem? Was he feeling maybe the moisture or the blades or the dirt or whatever, right? So what's going on? I want to know more about that experience and interaction for him. Okay, motor planning, under-attending, over-attending to a lot of these different areas. I have to go faster. I don't want to. Okay. Motor, because I have so many good stories and I can't tell any of them. Motor plan and timing, what does that look like? So this one boy, okay, it's time to go to gymnastics. He would love to go to gymnastics. He loves it. He can't stand up. Okay, so what does he need to help? Is it processing? For him, he'll tell you it's his motor system. He wants to stand up, but he can't get his body to move. So we're really learning so much from people with autism, maybe nonverbal, who are now using forms of communication to tell us their experience. It's fascinating. Okay, do we need minutes, seconds? Maybe it's not consistent, maybe it's not a constant time frame, but what does that look like? Okay, feelings and emotions, now we head into the amygdala. Why aren't you paying attention? Well, I need to regulate my emotions first. So this is a big deal. Emotions, memory, fear, a lot of this stopping. So one-time learning. So this boy comes riding his bike. It helped him regulate, gave him that tactile input, motor, planning, all that kind of great stuff. Rode the same path over and over. One day fell in a crack. Could not, moving forward, go past that crack. It was one-time learning. Boom, that didn't work for me. I'm going to fall if I go across that crack. So the parents worked with him day after day after day after day after day to get him past this idea that this crack is not going to stop him. Another student in high school, there was a bullying seminar. Hey, let's go to the bullying seminar. No, it'd be good for you, it'd be good for you. No, I can't do it. Finally, I was trying to give the old college try. Oh, it'll be great, it'll be fine, it'll be different from the class for a moment. And he said, stop, I can't go. When I listen to that information, it will take me 2 days to get back on track emotionally because it was too much for him to regulate that. It's like, oh, got it. He knew about bullying, he knew what it was, he knew not to do it, he knew it when he saw it. So doing that to him, that would not allow him to be in a headspace to move forward. Not a good thing to do. All right, so this is interesting. In the amygdala, children, 11% more neurons in the amygdala in young children, and then 20% fewer in adults. So we do see adults with anxiety, depression, and we see that emerge in adolescence as well. So we've got over-information in youth, less in adults. Pretty interesting. Okay, so I want to know, what do those feelings and emotions look like for these kids? What might this mean from a positive and negative perspective? And of course, there's a lot in between positive and negative, but it's a start. Okay, then we head into joint attention. Why aren't you paying attention? Well, I'm looking at that bug and you're looking at the stunning spring day. So that, again, that sort of visual idea. Joint attention is in there. That's probably not surprising. Active screens. What's going on in the mind of the child? How many different ideas are they thinking about at one time? I had a psychologist say one time, I know this child's not paying attention great in class, but he's got 3 other screens going on. He's developing a program. He's reading a book. He's got all these different things that he's doing. And right now, what's going on in those other screens are much more interesting than what the teacher's doing. So we need to tell him, okay, put that on screensaver, and let's listen to the teacher, and then when you're done, you can go back to what's going on. So really interesting to think about that idea of active screens and where that child's mind is and helping them understand where they need to be. All right? Or do they just need a break? Do they need a sensory break? Do they need something fun and interesting for a moment? Okay, so then I take a look at a lot of different options on what's going to maximize that attention and what strategies do we need for communication partners to help support learning. I only have 2 minutes, which means I'm supposed to stop. So I'll just show you the main headers. I go on and talk more about language and diving into language and what that means. I head into Wernicke's area. I head into Broca's area, the insula, really a lot on the information highway and what that means. Figuring out strengths, because yes, we can identify a lot of deficits, but let's focus on what strengths are. And then what communication looks like across different partners. Environmental awareness, are they aware of their environment? Sometimes our kids feel like if there's a lot going on, that's just almost it's a fight or flight, but almost to the point of feeling like they're in war. All right, and then environmental awareness, which is what I look at in the protocol. Okay, so theory of mind, located what they believe to be in the ventromedial portion of the prefrontal cortex. And some say there's actual neurons, but more people are thinking it's this idea of the information highway. Okay, then we can't forget the metabolic considerations. What's going on? How's this influenced for them? So I have a list of things for people to take a look at. Then at the end of this protocol, okay, what matters? What seems to resonate for this child? Is this a primary area of concern for attention? Is this a secondary area of concern for attention? Is this tertiary? Or maybe it's not applicable at all. I could probably add that in too, because that certainly could be the case. But then it starts to shape ideas and ways we can support kids. All right, and then the main message I'd like to take away is when I met with Dr. Sho, she's an amazing neurologist, and her child has autism. And she said, you know what, these kids are not being willful, they're not uncaring, they're not trying to be oppositional, it is possibly one of the characteristics, but they're living with this disability. Okay, it's right in their face. So it's easier for us to get in as the clinician to support these kids, to support the communication partners, and it is for them, the child with autism, to get out. And her message is we have to change to help support them. It doesn't mean that we can't help foster growth and development, but we really need to start focusing on understanding what's going on for that child and supporting communication partners so they can be successful. All right, I gave you no opportunity to ask questions. It is now 12:50, but I will stay here if you have any questions. And if there's anything online, I don't know if anything came through. No? Okay. So I will stay here if you have any questions. And I could go on and giving you 1,000 more stories. But anyway, thank you for your time.